Question number 9. As a whole, this question is of numerical solution of equation. As a whole, this question is of numerical solution of equation, but this part A, is of integration. The constant A is such that integration of x into e power negative 2x with respect to x with the limit 0 to a is equal to 1 over 8. This is given. Show that a is equal to 1 over 2 log 4a plus 2. We have to integrate this function with respect to x using the limit 0 to a. We have to show this relation 0 to a is limit x e power negative 2x with respect to x is equal to 1 over 8. We use here integration by parts. This is the first function, this is the second function. We are using here integration of parts because we have the product of two functions. We will take this x as the first function, e power negative 2 as the second function. We are using here formula for integration by parts. This is formula for integration by parts. This is formula, general formula. There are two functions. First function we write as such. Integration of second function minus in a sign of integration, and again integration of second function multiplied by derivative of first function. This is general formula. Integration by parts. First function integration of second minus sign of integration, and again we will write here integration of second function multiplied by derivative of first function. We are using here first function x, second e power negative 2x. We will use this formula here. Now this becomes first function as such. Integration of second function e minus 2x over minus 2 minus sign of integration. Again we will write this here e minus 2x integration of second function derivative of first function because first function is x derivative is 1, so we are writing here 1 dx is equal to 1 over 8. Now rearranging minus x over, we are setting this term, we can write it as minus x over 2 e power 2x. This minus and minus plus. We can take common because 1 over 2 is just a multiple. E power negative 2x with respect to x is equal to 1 over 8. Now we will again integrate this function. Now only one function is only one function lies here. So this become minus x over 2 e 2x plus 1 over 2 integration e minus 2x over minus 2 is equal to, with the limit 0 to a is equal to 1 over 8. Now we are setting this term minus x over 2 e power 2x minus 1 over 4 e power 2x with limit 0 to a is equal to 1 over a. Now we are putting the values. We will applying the limits. Upper limit is a, lower limit is 0. Applying the upper limit, in place of x we will put a first. Then we will put 0, that is the lower limit. Before applying the limit, we can take common negative sign because negative sign lies in both terms. So we can write it as minus x over 2 e power 2x plus 1 over 4 e power 2x. 0 to a is the limit is equal to 1 over 8. Now applying the limits, minus remains as such. We are supplying the upper limit, that is a. In place of x we are putting a over 2 e power 2a plus 1 over 4 e power 2a. Upper limit minus lower limit is 0. Now we are putting 0 in place of x. 0 plus 1 over 4. Putting here x is equal to 0, it becomes the term as a whole becomes 0. Putting here x is equal to 0, it becomes 1 over 4 is equal to 1 over 8. Now simplifying we get minus a over 2 e power 2a minus 1 over 4 e power 2a plus 1 over 4 is equal to 1 over 8. We have to show this relation. We have to make a the subject. We have to show this relation. Now multiplying by, or simply we are writing it this 1 over 4 moves to the right side. It will be minus 1 over 4, 1 over 8 minus 1 over 4. We can simplify, that becomes minus 4. So this will be minus a over 2 e power 2a minus 1 over 4 e power 2a is equal to negative 1 over 8. Now multiplying both sides by negative number because there are signs of negative signs lies on the both sides. We multiply each side so we may have the positive values. So we can multiply each side by a negative number. This becomes, or simply you can say that we are taking from left side negative 1 common, a over 2e power 2a plus 1 over 4e power 2a is equal to negative 1 over 8. These signs are cancelled out. Now we get taking common. Uh, we can take common 1 over 2 from both sides. After cancellation, we get a over e power 2a plus 1 over 2e power 2a is equal to 1 over 4, because we have taken 1 over 2 common from the left side, and it will be cancelled with 1 over 8, it becomes 1 over 4. So now we try to show that the given relation. Now we can take common 1 over 2a, because 1 over e power 2 is common in both sides, in the left hand side, in the both terms. So we can take common 1 over e power 2a within bracket a plus 1 over 2 is equal to 1 over 4. From here, we can write a plus 1 over 2 is equal to e power 2a over 4. Now, taking LCM of left hand side, it becomes 2a plus 1 over 2 is equal to e power 2a over 4. Multiplying by 2 both sides, this 2 will be cancelled. In place of x, there will be 2. So we can further simplify it. 2a plus 1 is equal to e power 2a over 2. From here, uh, e power 2a is equal to 4a plus 2. Not taking log each side, log e power 2a is equal to log 4a plus 2. Now using log property here, this 2a becomes down. It becomes 2a log e is equal to log 4a plus 2. Log e is 1. Log e will be 1. So from here we can make a the subject, that becomes a is equal to 1 over 2 log 4a plus 2. Hence the given relation is shown. We have to show this relation. The second part of this question is verify by calculation that A lies between 0.5 and 1. This part of the question is of numerical solution of equation sign change rule. The first part, that is part A, that was part of integration. We have to show this relation, and this part B is also related to that first part of the question. Verify that by calculation that A lies between 0.5 and 0.1. We will use here the sign change rule. So first, just we have shown this relation. A is equal to 1 over 2 log 4A plus 2. No, these are two separate functions, A and 1 over 2 log 4A plus 2. We are merging these two functions. We can write a single function. So fa function of A will be A minus left right side, the term that is in the right side move to the left, that becomes minus A minus 1 over 2 log 4A plus 2. Now we will put these two values 0.1 and 1 in place of A separately. We are putting these two values separately in this function. Now then we will check the sign. We need the opposite sign, that, and this shows that the question follows the sign change rule. So first, it is very important that first you have to set your calculator mode on radian. So first we put 0.5 in place of 0.5 in place of A, that is 0.5 minus 1 over 2 log 4 into 0.5 plus 2. After using a calculator, we get after simplifying this, we get here 4. After calculating, we get the value of this, that is equal to negative 0.193, or clearly this is negative. This is less than 0. And now we will find f1, f1, putting 1 in place of A in the same relation. We get a 1 minus 1 over 2 log 6. We get, after calculation, we get 0.104, or clearly this is positive. These opposite signs, f 0.5 gives negative value, f1 gives a positive value. These opposite signs shows that the root lies between 0.5 and 1. This is verified. Now part C of this question is use an iterative formula based on the equation in A to determine A correct to two decimal places. In this question, A is approximated root. Give the result of each iteration to four decimal places. First, we write the formula, iterative formula, because the iterative formula is not given, but it is based on this part. Now we will use this relation to make a iterative formula, because the iterative formula is based on part result of part A. Result of part A is this, which is highlighted. This is the way to make the iterative formula. On the left hand side, the relation is this: A is equal to 1 over 2 log. Relation is A is equal to 1 over 2 log 4A plus 2. But to make a iterative formula, we write here in the left hand side, in the bottom of the variable we write n plus 1, but on the right hand side where the variable lies, we will write in the bottom, that is n. So this becomes a formula that is called iterative formula. When the iterative formula is not given, then we make iterative formula like this. Now this is iterative formula. Now we will find the different iterations up to 4 decimal places. For the final answer, we have to give in 2 decimal places. So we will find the different iterations. No starting iteration, yeah, first iteration is not given, so we will take help from this. Root lies between, by where is that alpha or root lies between 0.5 and 1. So which we are taking a suitable value between 0.5 and 1, that is, we are taking the mean value of this 0.5 plus 1 over 2, we get 0.75. So we are taking this as a first iteration. So we are taking A1, that is the first iteration, 0.7. Now have to find next iteration, that is A2. To find A2, we will put here n is equal to 1. Then we can get A2. In place of n, on both sides, we will put 1. So putting n is equal to 1, we get on the left hand side A2, A2 1 over 2 log 4A1, because we are putting n is equal to 1 plus 2. Now we have the value of A1, that is 0.75. Putting here, A2 becomes 1 over 2 log 4 into 0.75 plus 2. After calculation, set your calculator mode on radian. We get this. After calculation, we get 0. Correct to 4 decimal places, 0.8047. We will calculate it by calculator. We get this 0.8047. Now in the same way we will find A3. A3 will be, now we will put n is equal to 2 on the both side. Left side A3, right side 1 over 2 log 4 into value of A2 is 0.8047. So we are putting here 0.8047 plus 2. After calculating, we get it A3 correct to 4 decimal places, 0.8261. This is the third iteration. Now A4, just the iterations are not converging. Next, we have to find it 4. that is a 1 over 2 log 4 into A3 is 0.8261, 4 into 0.8261 plus 2. After calculating this, we get 0.8343. Now A5, 1 over 2 log 4 into A3, A4. A4 is this 0.8343 plus 2. After calculating, we get 0.8374. Now, just this is iterations are not converging, root is not converging. So we have to find the next iteration A6, 1 over 2 log 4 into A5, that is 0.8374 plus 2. After calculation, we get 0.8385. Now uh, it is converging because the answer, these are different iterations. Here the root is converging because correct to two decimal. We have to give the answer correct to two decimal places. The if we rounding off this iteration, we get 0.84 correct to two decimal places. And in the same way, if we could the rounding up this iteration A6, this is also a 0.86. This shows that we get approximate root from these two iterations. From final iteration, we will write here correct to two decimal places. So we get A is equal to the approximated root is represented by A. So we can say that final answer A is approximate root. A is equal to correct to two decimal places 0.84. This is the answer.